Let's have a look now at parallel lines and perpendicular lines. We've already met straight lines before. We know that a straight line is something that has constant gradient, so when I look at the change in y and I divide by the change in x, I always get the same value, which we usually attribute the letter m. Now, if a line is parallel to this, it means that its gradient is going to be the same. So the key takeaway is that parallel lines will have the same gradient. Absolutely key, parallel lines have the same gradient. So in this case, line L is parallel to a line with this equation and passes through a separate point, and we're now to find the equation of line L. Well, the fact that it's parallel means that the gradient is going to be the same, so the first thing I need to do is to extract the gradient from this equation. I can only do that when y is the subject, so I need to start off by saying that this is 4x minus 1 is equal to 10y, and dividing through by 10 is going to give me 4/10 of x minus 1/10 being equal to y, or tidying up, 2/5 of x is minus 1/10 is equal to y. Now it's got y as its subject, I know I can just read the gradient straight from the coefficient of x. So the gradient of this line, I would say m is equal to 2/5. We want to find the equation of the line that's parallel to this and goes through a certain point. So back onto my favourite equation, y minus y1 is m lots of x minus x1. What do we know? Well, we know it goes through this point, so the y value is 7. I know it's got the same gradient because it's parallel, so that's 2/5. And I know that this is going to be minus 2. I'm going to multiply through by 5 to say that's going to be 5y minus 35 is equal to 2x minus 4. And then I'm going to rearrange that to say that 0 is equal to 2x minus 5y plus 31. And that's all we have to say about parallel lines. Key point, parallel lines have the same gradient. Let's look now at something slightly different, which is going to be our perpendicular line. Now, to start with, we do the same thing. We look at the gradient, so we want to find the change in y, so let's call that the value a, and the change in x, and then let's give that the value b. Now, what does a perpendicular line look like? It would go through here at 90 degrees. So all I've done is I've rotated my line round through 90 degrees. Now, if I do that, when I look at the change in y this time, the value is going to be the same as b, or the magnitude is going to be the same as b. It's just a negative. Okay, because this line has got negative gradient, so my change in y is going to be a negative value, but it's going to have the same size, so it's just here as minus b, in the same way that my x value at the top here would be a. All I've done is I've rotated round through 90 degrees to get these values. So, what am I saying? Well, the gradient of the original line, m, is change in y, which is a, divided by change in x, which is b. The gradient for my perpendicular, which we often refer to like this, a little symbol here where one line meets another at 90 degrees, is going to be change in y, which is minus b, over change in x, which is a. Now what happens if I multiply those two gradients together, m and m perpendicular? Well, that would be a over b multiplied by minus b over a. The a's will cancel out, the b's will cancel out, and I'm left with minus 1. So I know for a fact that two lines are perpendicular if, and only if, when I multiply their gradients, I get the value negative 1. This can be really useful for me because I can rearrange this and say that m multiplied by m perpendicular is equal to minus 1. So the perpendicular gradient is going to be equal to minus 1 divided by m. That's a very useful fact that we can use over and over again. So in this case, we want to look at these lines and decide which of them are going to be perpendicular. Well, that's going to require me to rearrange to make y the subject so that I can read the gradients off straight away. So for L1, I would have, let's say, x plus 2 is equal to 4y, or 1/4 x plus a half, simplifying straight away, is equal to y. So there I go from the first line. So the gradient of L1 is equal to 1/4. Let's then look at L2. Rearranging this one, well, that's going to be 4x plus 2 is equal to y. That's nice and straightforward, so the gradient for L2 is equal to 4. Subscripts here, this is exciting. For my third line, I've got x minus 3 is equal to minus 4y, and if I divide through by negative 4, I've got minus a quarter x plus 3/4 is equal to y. So my gradient here, m for L3, would be minus 1/4. Now there are only two of these lines that are actually perpendicular, and that's going to be L1 and L3 and L2, because when I multiply the gradients together for line 3 and line 2, what do I get? Well, writing it out, I've got 4 multiplied by minus a quarter, which gives me minus 1. So I can say that line 2 is perpendicular to line 3. A bit wibbly here, but again we're using this perpendicular sign where I'm just drawing two lines at 90 degrees to each other. Saves me time, and everybody's clear on the meaning. In my final example, I've got a line that's perpendicular to another equation and now passes through a separate point. So we go through the same process. We start off by looking at our line here, and we're going to say, right, if it's perpendicular, the first thing I need to know is what is the gradient of the line that I've been given. So that would be rearranged to 3y is equal to x minus 4, or y is equal to 1/3 of x minus 4/3. Now, from a couple of slides ago, we know that the gradient for a perpendicular line is equal to minus 1 over the gradient of the original. So for my perpendicular line, the gradient is going to be minus 1 over 1/3, which is the same as minus 3. Now I've got the gradient, I've got a point, I'm back to my favourite equation, y minus y1 is equal to m lots of x minus x1. Y minus minus 3 is equal to minus 3 lots of x minus 3. Too many 3's going on here. So the 3 here comes from the y value, the negative 3 here comes from the perpendicular value gradient, and the 3 here comes from the x value. What does that give me? Well, that's y plus 3 is equal to minus 3x plus 9, and rearranging that, y is equal to minus 3x plus 6. Absolutely key. When two lines are parallel, they have the same gradient. When two lines are perpendicular, the relationship between the gradients is this, that the perpendicular gradient is negative 1 over the original, and that obviously always leads to the fact that m times by m perpendicular is equal to negative 1. If you're ever asked to prove that two lines are perpendicular, then we always multiply the gradients to show that we get the value minus 1.